Hello everyone and welcome to today's webinar between Zoller and Hexagon, Smarter Connected CNC Processes to Enhance the Efficiency of Your Machine Shop. I'm Michael Folger, I'm the Marketing and Video Production Specialist at Zoller Inc. and it's my pleasure to be the moderator for today's webinar. I look forward to being here for the presentations as well as the Q&A session at the end, which I'll moderate. Before we get to that and to the technical presentations, I just want to take you all through a brief bit of history and information about the presentations you'll see today. So we'll get into this here. A little bit of background information about both Zoller and Hexagon before we start. Zoller as a company was established in 1945 in southern Germany, and Zoller provides cutting-edge solutions for tool presetting, tool measuring, tool inspection, automation, and the focus of today's webinar, tool management software and hardware solutions. Our focus in particular today will be on cutting tool data management for CNC machining from the Zoller side. Then when we switch over and look at Hexagon, Hexagon was established in 1819 and is a global provider for smart factory, including metrology, production, and engineering software. From the Hexagon side, Hexagon will focus today on CAM programming and G-code verification in CNC machining. So a little bit about the Zoller and Hexagon partnership as we get started into the presentation today. What is this partnership and what does it do for you? The partnership between Zoller and Hexagon allows you to connect tool database, TMS tool management solution software across programming processes and transfer a full setup sheet for any particular job that you're working on, that full tool list. It also allows you to transfer a single tool and use realistic tools in your CAM and verification generated by Zoller's TMS. This means you ensure valid tool data, you eliminate any tool data redundancies, and you accelerate your EDGECAM and NC symbol preparation. So there's a significant benefit to the partnership between Hexagon and Zoller, which you'll hear a little bit more about in detail as we get further in this presentation. So here we take a look at a typical CNC manufacturing workflow, all the way from the left side of your screen there with engineering and design to the right side of your screen at the end of the workflow with QC and inspection. So of course you see the highlighted portion in the middle there in green is really what we're going to be focusing on from tool design until validation and verification, and that's where between Zoller, EDGECAM, and NC Symbol the majority of our process is going to be covering today in that manufacturing workflow. So we have three presenters on hand today, one from Zoller and two from Hexagon, who are going to take you through that process. First, it will be Cedric Hasenfratz, National Sales and Partnership Manager at Zoller. He'll take you through the Zoller side of things with our TMS tool management solutions, which I mentioned. Then you'll hear from Joe Sanders, who's the CAM Applications Engineer at Hexagon. And finally, Christopher Parker will finish things up with G-code. He's the G-code Verification Applications Engineer at Hexagon. So like I mentioned, I'll be moderating the Q&A discussion at the end of this webinar. So please, if you have questions, do look for that questions icon and submit your questions there. I'll be paying attention to those questions as they come in throughout the webinar today in the three different presentations that we have. Go ahead and submit those and we will discuss them with the experts from Zoller and Hexagon at the end of this webinar. So without further ado, Cedric, I'm going to pass it off over to you now and I'll let you get going on Zoller TMS.
Thank you, Michael, for the introduction. It's nice to see the partnership between Hexagon and Zoller, and I have the pleasure to kick things off today to really show you a nice, efficient manufacturing process where Zoller TMS, Tool Management Solutions, comes in as the first source to have a complete, nice, clear organization of your tooling and warehouse management. As you can see on this slide, we have a shop floor where we have cabinets, we have presetting machines, machines in the back that need to be completely organized and really being efficient, getting the job done the first time right. As per Zoller, again, the clear goal is here to have a clearly organized tool and warehouse management, which shows the first picture really well. This goes right into a complete efficient manufacturing organization because you have your tools there, you have your tool TMS platform right next to it, and really can, find instead of searching of your tooling equipment, and everything is right there to connect your dots with your presetter and the actual CNC machine. Today, of course, especially, how can we transfer all the tools to your programming system and then also verify it after? And we'll show you, of course, on how this can come all back into the Zoller database, which we call the one central database. and really the big link to combine all the other solutions you're going to see today to have a really clear view with correct tools and tool information. That central database is really beneficial with the Hexagon products because we really support all their CAM systems they have in their portfolio, which is really a great benefit for you as a Hexagon user to being able to really transfer it with any type of CAM from Zoller. As a next step now, I'm going to give you a quick more, little input on the actual TMS side of things, on how things look. We see here on that slide, and we show that a little live in just a few minutes, the components on how is this specific turning tool or cutoff tool being assembled. We see here there is the actual inserts with set screws, the actual holder. So you see the whole component level of that specific tool. You're able to create your 3D and 2D graphic, as you can see immediately. It generates it automatically for you. And that's a really big benefit right there, to have that nice database there ready to go. As the next step, if everything looks good, you can export and transfer tools to EDGECAM. There's a button, like a little C-hook, to import everything right from EDGECAM with the Zoller C-hook into the EDGECAM interface. As you can see, there is information also about speeds and feeds. So there is technology data. I think at EDGECAM they call it the geometry data that you can be transferring right over. And last but not least, if you do work with EDGECAM and everything looks good, or for example, also use NC Sim and verify everything, in EDGECAM, for example, you also can just bring it back as a complete setup sheet and re-export it to Zoller. That way you know now all my products are 100% correct, all my tools are 100% correct, and I'm good to go for the next job. I know everything has been verified. In the middle, you see the Zoller screen, including the presetting information from the Z and X tolerances, plus the actual printed out setup sheet with the drawings on it and some more information about that tool that has been measured on the presetter and also being defined within the Zoller database. Here are quick generic interface specifications to take a look at and what we're actually going to transfer. Pretty sure you guys saw, well, what are you really transferring here? We are going to show you that in our demo in just a minute. As an overview, it's really nice to see that we can really combine all the characteristics based off the ISO 13399, like EDGECAM works, to be transferred as complete tools. And what type of tools? We have drilling, milling, or turning applications. Complete tool transfer with contours, so step file and STL file, doesn't matter. And the real nice thing again is once everything is verified and really done, you can bring this over as a complete setup sheet right back to Zoller, and those guys know, hey, that setup sheet for that job is 100% verified, it's working, and those tools are correct to use. So without further ado, I'm going to go and head out now right to the actual demo piece of it to give you a bit more input on how this all works within the Zoller database and EDGECAM. Tool preparation. So basically we have ID numbers for each tool. In this case, you have a complete different group. For example, milling tools. Here we see a nice milling tool, an end mill with the 2D graphics that you see right here, and also a 3D graphics that's been generated, like I said, automatically, or you can also bring it in from your vendor. But generally speaking, Zoller TMS will be able to help you with that right on the spot. And here's the CAM side of things, that you can use that graphic too. So all those three graphics now are completely attached with that specific end mill. So everything looks good, I confirm. And now I can just quickly also look at a actual contour of my tool with the cutting part and non-cutting part that you see right here in green. And last but not least, like I mentioned before, here is your component. If you're not sure about certain components, you don't know exactly what it is, you can actually pull this out. You see on the right side, there's a quick story of who created it. Is there any specific components attached to that, like a set screw or anything? And last but not least, again, this is the ISO 13399 with the complete characteristics of that specific tool. So all the diameters are right there for you, and automatically that 3D is created on the spot. So we have that now completed. Let's go and take a look quick one more time at those characteristics of EDGECAM. So as a complete tool assembly now, you see all the characteristics again. And this is the information that we are going to transfer now to our CAM system. Again, EDGECAM will exactly read on what Zoller has in here, and only of course what's filled out will be transferred to the CAM system. What's nice about this is too that we do have the technology data. We're talking about what material can be cut, different applications such as what machine, what's the actual finishing, is it a surface finishing? You can define that multiple times with the same tool. Then we're going to take a look at a drilling tool. We're going to really show you all the possibilities and applications that we can transfer over to the CAM system. Same way, we have 2Ds and 3D graphics. Here's a really nice one of the drilling tool. You can even see an actual collet component that is connected between the drill and the holder. Then same thing, you got the components all there, same characteristics of EDGECAM, and we have also a turning tool that we would like to show you today, so that way we show you all applications that are possible to be transferred. So this is the one that we're going to use later on for the cutoff of the part. And the same here, you have the complete parts list. Characteristics, same way, you have everything that you need to transfer now as a complete tool assembly. Here are your AP connections for end mills, all different examples, which is really powerful here. You can really define specific turning tools. You can define specific drilling tools, which is very unique to a tool management system to be defined. Well, how does the import work? We are going now to look at the database within EDGECAM. Obviously, this is an empty database, just to confirm for milling and turning, nothing in there. Okay, so what we're going to do now, use the C-hook of ZOLLER TMS right on the top left, and we are now going to try to get those tools in from our worksheet, the import. We can choose either in millimeters or inch. In this case, you're going to use inch. We're going to also define out what portion and data that needs to be imported, and also the actual import, the order of it. So we're going to really make sure we're going to go in order and which tools are we going to import and which one is next. So this is what we're going to define right here. And we confirm. And now you're going to see shortly a quick process on how everything comes in. As you can see, there's the material that comes in from the tech data. Everything is running down right here on the left screen that you just saw. Now let's look at the tool store. Did it really bring in everything we needed? Yes, there's the milling, there's the turning tools, and the drill is there too, I see. And here's the tool identification numbers that you can see. And really nice here, you have the turret position already ready for you right there. Also the geometry data. And again, we're talking here about that tech data from before on what type of material it can cut. As you can see, N28 use that we showed before in Zoller. Confirm this. And we're going to keep now assigning everything, make sure the positions are correct with the basic position that we need. And here's that cutoff tool also showed in TMS. Same procedure, look at the geometry data real quick. And again, we have one more milling tool that we would like to define. Get a quick view of that tool. Again, that's the complete digital twin of the ZOLLER TMS tools that we created in our central database. So everything looks good here. I confirm. Again, everything now we do assign to the job that we see here in the middle. So that way at the end we are able to run an actual simulation too once everything is completely assigned to it. Again, here's a radial cutter, also defined now and confirmed. And when everything is done here and assigned, we start the simulation. Cutoff tool comes in, makes the cut, and that basically is the whole ballpark of the ZOLLER TMS import. Let's say everything looks good. The simulation worked well within EDGECAM. We can now use that same worksheet and would like to export that over to our ZOLLER TMS database. Again, it's running all the information here of each of the tools of that specific setup sheet, because the actual import will be a complete setup sheet that has to be transferred over. So, setup sheet, how does that look? In Zoller, it's now transferred. We're going to take a look quick in our module of setup sheets. We are opening up our groups, and here it is, the part of webinar EDGECAM, that's the one, confirm. And now we can enter some more information if you needed to. Here are all the tools, again with the information also from the presetter, including the graphics attached. So everything now is nicely verified and shown for each tool with all the measurements of your presetter, all the information that we took over from EDGECAM, that those tools are really now fully good to go and can be used at any time for the next job. How does that look for the operator? If you want to make printouts or on a screen on the shop floor, we have some nice printouts that are customizable within Zoller. You can create those on your own with the main page, and here you can see some nice real data with the graphics, all the information about the tool that you need. And again, you can have 4 or 5 tools on one page. That's really up to you, but just as a nice example to show. So if you want to learn more, go to Zoller and see what's there to learn exactly how we transfer digital twins to different CAM systems. And today was a really nice example of EDGECAM. So thank you very much. And again, don't forget, why are we doing this? Since we showed 2 providers today, it really is important that we have that full link to have that central database where you can push out your tools to multiple systems, and you have that central database that's verified and corrected, and you really are ready to go on your CNC manufacturing process. Without further ado now, I'm just going to head it right over to Joe Sanders, the application engineer over at EDGECAM, and I thank you already on behalf of Zoller looking at our part, and I'm excited to see what Joe's going to show you. Thank you.
Thank you, Cedric. As we begin the EDGECAM portion of the demonstration, I want to begin at the tooling database. EDGECAM's tool store database is our customer's virtual tool crib, and in this case, working with the Zoller data, the database is a mirror image of the data from Zoller. So when we look at this tool package, let's start with one of the turning-based tools, the part-off tool. And we see that the excellent graphical data as well as the very important numerical data is correctly captured. The data from Zoller has been handed off to EDGECAM, and our database is a mirror of theirs. When we look at the tap, Cedric had selected a tap that not only, again, we have the good holder data, but we also can accurately see the business end of the tap that Cedric had also displayed. Again, the graphical and numeric data is perfectly mirrored in the EDGECAM database. So let's go begin the CAM process. I'm going to begin by taking in a brand new solid model, and we'll quickly prepare the model for machining and build some quick tool path. When EDGECAM loads the part in, we might want to reorient it, and for some customers that might mean flipping the part the other direction. This is actually the way I want it for this setup. Very easily done. Another common orientation that might be important in a turning center with live tooling is to consider where the C-axis 0 orientation would be. In this case, that's the 3 o'clock position. So I'm going to go and pick a C orientation, and I'm going to go select this open pocket right over here. We can see that that is roughly 9 o'clock on the right-hand view. When I select it, whatever angle is needed, the part is rotated so that that is the new position. That's great. Let's turn off that right-hand view now that we've demonstrated that quick orientation and resume with getting the CAM file ready for the machining process. We'll select the material to use. We'll choose stainless steel for feed and speed lookup, and then add a stock to the part. This is a part-off situation, and I want to put in a material that allows at least a simulation of a couple of part cycles, 2-inch bar. We can see that EDGECAM shows the material. We see the stock position in there, and this looks like what we want, so we'll continue with now connecting this to the CNC machine. Out of the different machines in our shop, we're going to choose this machine here and the tooling package from Zoller. Let's ask for a 3-inch part stick out, and with some brief guidance, the machine is now assembled. We can see that this machine includes graphics of the machine tool, and that this is a twin spindle machining center with an upper swinging head. So certainly some collision risk. We want to make sure that we're building a good CAM program. Let's turn off the display of the machine for the moment and focus in on feature recognition as the next stage. In this stage, EDGECAM is going to be directed to quickly collect machinable data for our setup. The programmer can direct what they're looking for. On the live tool side, I do want to make sure we're getting open pockets, and I'll determine which faces we're doing the machining from. So we need to do live tool machining from this direction, and there's also a flat on the other side. So those three directions. And with that quick piece of input from me, EDGECAM completes the feature recognition process. There are a couple of features that I don't need to manufacture on this setup. In the main spindle side, there are a couple of holes in this flange, and they go through the part, and we'll wait to do that on the sub spindle side. So I'll opt out of that for this main spindle focused features. And that quickly, we're now ready to begin the CAM process. Let's start with going to the tool database and choosing a suitable tool. So I'm going to choose an 80-degree roughing tool. We see a preview of that tool, how it's loaded at a 45-degree head angle. When we select that data, all the tool data is loaded down to CAM, including turret position, all of the data known, right from the ZOLLER database, passed through to CAM. Let's use a yellow color for the visible tool path. And with the tool path in place, we'll now use EDGECAM's knowledge-based machining to build roughing tool path using the current tool. Let's work on the face and the turn cross section. Features are smart pieces of geometry. They include not only the geometric data, but often a wide range of other useful information that a programmer would typically need to know. And knowledge-based machining helps the CAM system make appropriate programming decisions based on the intelligent data of the features. We can see that tool path has been built, and we have a rough turning command that does an adequate job of removing material, but it ends where the feature ends, which is at the back end of the outside diameter. Well, that is suitable, but we can improve it a little bit. What I want to do to begin with is think about EDGECAM's awareness of the stock and fixture. We have a directive here that I'm going to change to say stay 1/8 of an inch away from our fixtures, and if we're in rotational indexing, 1 inch away. With that brief direction, we're now going to take the rough turning command right here, and we're going to modify it. And we're going to direct EDGECAM to put a ridiculous extension of 10 inches, but then we'll also say, since you're aware of the current work holding, collision check off the main spindle. And with that brief directive, the rough turning is improved to now extend until it's 1/8 inch from the fixture, and this is much better suited to the part-off condition that we're looking to program. Due to time, I'm going to go load the finished completed program. We'll use the CAM simulation to preview the process and make sure this is collision free. So we're watching for a wide range of collisions, and we've directed the CAM system to stop if you have any collisions. And so CAM simulation shows us the tool moving through the part. We can see that. Well, let's go ahead and turn off the display of both the enclosure and also even the ancillary items and focus in on the part itself, the things in the machining envelope that are collision risks. Now we can see here that this tool, coupled with the extension, has suitable length to avoid collisions. So Cedric did a great job of selecting the proper tool. We can see that for some tools that are mounted at a 45-degree angle for even better avoidance, that again, collision free. As we bring in the live tooling, we can see the live tooling work. And next one up is going to be the tap. If I pause, we see that the tap again is an accurate representation using the ZOLLER data. We see simulation that shows both C-axis movement as well as XY based movement depending on what the CAM selection by the user was. And again, everything's collision free. Now we're going to get to a point in the program now, following some work with our tap tools and then driven tools, where the part off tool is going to come in and we're going to have some, probably the highest risk of collision in the process. So let's slow this down. We'll turn the display of the machine back on. We'll look at the full machine, and I'll leave the enclosure on for the time being. As we play the simulation, we see the subspindle move toward position, and this is a really critical thing to make sure we don't have any problems with. And we can see that, nope, there's no problems at all. Again, proper tool selection, the work, holding, and chucking systems that we have selected will all be able to be used. So I'll speed up the process now, and we can see again the rest of the work happening on the subspindle. The process looks good. It was collision free. At this point in the process, the user would then generate the NC code file. This NC code file captures all motion here, the turning tools, the driven tools, the subspindle handoff, everything. And we count on this being edit-free code. But we do want to do a final check in NC Simul. We'll use the NC Simul link that's in EDGECAM to generate a package that we can immediately export, and we'll now send to Chris Parker for G-code-based verification of the CAM system G-code in NC Simul.
Thanks, Joe. So this is what it looks like when it comes into NC Simul, and everything's transferred over and it's set up in the same exact way that you would see it on the shop floor. You have the machine that it's running on, the DMGE CTX. You have your setup on the chuck and spindle, and with your fixturing, your part model, and the rough stock to be machined out. Any of the coordinate systems that EDGECAM have are going to be brought into and available. And you have the main spindle as well as the sub spindle, which the part's going to get transferred to at some point in the process. You also have all of your tools. So these are the exact ones that started inside Zoller. And you can open up the magazine and get a good look of all of the 3D models. So there's a series of them that came from Zoller to EDGECAM and eventually to us. And if I back out of that, we'll just have our initialization so NC Simul knows where to place the program in space. And finally, the post-process G-code, the exact same one that your real machine is running. And inside that, it's broken up by tool sequence. So every time the tool changes, you can elect whether to start at that sequence or start at the very beginning. And then on the right-hand side, it's that same post-process G-code plus any subroutines or macros that the real machine is running. So for instance, if a tool change is called, the exact macro that's running in the background of your real machine will be simulated inside NC Simul, and it makes it really good for both cycle time and to make sure that there's there isn't any unforeseen collisions that are going to happen throughout the process. So I can go ahead and start the actual simulation, and inside this, we'll actually see the material removal come off the part. So it's going to start on the chuck on the left-hand side, and this is the full machine view where you see all of the axes in motion. I can also switch just to table view, or I can go ahead and split the display side by side for machine and part so you can get a good idea of seeing both at the same time. And at some point, it's going to transfer from the main spindle over to the sub spindle and continue the simulation. I'm just going to speed it up a little bit so we get to that point. So there's the part transfer. And then ultimately, at the end of the day, once we get all the way to the end, we're able to go ahead and take the comparison of that part. So it's comparing the original part model that we started the programming process from to what the post-process G-code just cut. And if you're inside the green, you're within your tolerance. If you're red, it's gouged areas. So in this case, the part model didn't have the threading, but we simulated the threading inside NC Simul so we can verify and take measurements off that. And if there was any excess material or areas that we missed, we'd be seeing that in blue as well. So that's the three-step process. Make sure that nothing would alarm out the real machine. We run the simulation, make sure that there aren't any collisions. And finally, we compare it to the original part model to make sure that we're cutting a good piece. And at that point, you could feel fairly confident that you could send out this project or process to the shop floor, run it lights out first time. You wouldn't have any collisions. and there wouldn't be any need to sit there at the machine and go block by block. We've verified everything in the digital twin machine ahead of time.